In this section, we'll look at tables and geocodes, which is part of the Chapter 4 section from your tutorial dealing with geodatabases. So the first section, the first slide set deals with tables and geocodes. Then later, we'll talk about data table joins, spatial data formats, geodatabases, and calculating geometry. There are two types of tables in ArcGIS. First is the feature attribute table of the map layer, where the attribute data is a direct part of the map layer itself. You right-click on the layer in the table of contents, and the attribute table comes up on the screen. It shows the features as rows and the attributes as columns. Then there's also a data table with geocodes, such as census IDs. In this case, you can add this as a table to ArcMap, and then join the table to a map layer to add more attributes to your layer. You may join via the same geocode values in both the data table and the map layer's attribute table. For example, you'd need to have a unique identifier, a field or a column in this case, in which you have some kind of information that is going to join the two together. Here's a census data example. Too many census data variables are available to supply in the feature attribute table, so you can download a custom table and join to an appropriate polygon layer. You'll end up joining those together by using a unique identifier. Here's what this would look like in data table format. So in this case, a rectangular table with one value per cell. The columns or fields are attributes, and the rows or observations are the records. The first row must have column names that are self-documenting labels. For example, the shape. An example like POP 2000. The first character of attribute names must be a letter. So this is one of the characteristics of the database setup. The first character of attribute names must always be a letter. It may not be a special character or a number. Remaining characters can be any digit, letter, or the underscore character, but there may be no blanks. All additional rows of a data table must contain only attribute values, such as raw data. None of the rows may be sums, averages, or other statistics for raw data rows. Each table has a primary key attribute with two properties. Each value is unique, and there are no null values. For example, the field ID you see here in this attribute table. The field calculator may be used to add computed columns to ArcGIS. You do this through the field calculator because ArcGIS does not have the capacity in the query section of a relational database that allows you to compute new columns on the fly. So you must create permanent new columns. There's a full range of computation that may be done, adding, multiplying, dealing with numeric and text functions, concatenating text values, which means putting them together, taking them from two separate cells and putting them together as a string into one. Here's an example of the field calculator that you'll be using with your lab tutorials and your lab exercises and assignments in Chapter 4. So in the numeric functions of the field calculator, this shows us the various fields that are available. If you notice, the list of fields matches those in the attribute table. So the list of fields in the field calculator are in the same order as the ones in the attribute table if you were to look at it in more detail. And then you can select the functions that you want to do, and then go ahead then and create a new field from the result of the two fields that you're working with to create that third field. For example, you may want to concatenate house numbers and street fields. That would be going from having the street underscore num field with the street number in a separate field from street name. Maybe you want to put them together into the same field. You do this by adding a field and then bringing up the field calculator and selecting street number and street name, and then click OK, and the result is a single field that shows you the full address in one field instead of two. Another thing that can be done is to import external table file formats or files into ArcGIS. There are several different field formats that will work. One of them that's an important one to use is the CSV, comma-separated field value data, which comes from plain ASCII text. It's a very transportable format for very large files. Each table record is a row terminated with a line break character. This is an invisible and non-printing value. It has values separated by a delimiter, usually a comma. For data values that contain the delimiter, enclose the value in double quotes. Sometimes columns get wrong data type on import, and you can use the double quotes to force the text data type for digits. You'll see this in your lab tutorials when you go through Chapter 4. Another option is to use Excel data, which may be brought in to ArcMap and then joined to tables in ArcMap. Then there's DBase, which is a database table, .dbf. This is a legacy format, which means that it predates many of the other database systems. ArcMap uses a DBase system that truncates field names to the first 10 characters, and it has a maximum of 255 columns. You can open a DBase file in Excel, but you cannot save it as a DBase itself. Another option is to use Microsoft Access database data as well. Next, we'll talk a bit about geocodes and how they can be used in manipulating data and bringing tables together. First of all, it's important to remember the FIPS code system, the Federal Information Processing Standards. This was developed by the National Institute of Standards and Technology, and it creates codes for place names throughout the world. Each country, states and provinces, counties, metropolitan statistical areas, cities, and places all have a FIPS code. And then there's more information and a link that you'll find in the course if you want to know more about how these FIPS codes actually are set up. So for example, if we were to break down a FIPS code for a place, here's one for the city of Pittsburgh. So country US, state is 42, that's Pennsylvania, that's the code for Pennsylvania. County 03003 for Allegheny County, and then minor civil division 61000 for Pittsburgh. So 42003 61000 would be the FIPS code for Pittsburgh. A census code is another thing that could be added to this with statistical boundaries for census tracts. So for tract 1917 and block group 003 and block 005, here's what you would end up with. US 42, that's for Pennsylvania, 003, that's Allegheny County, 1917, which is the census tract, 003 is the block group, and 005 is the block. Notice that in this case, you missed the minor civil division and went straight from the county to the census tract, block group, and block. Then local government cadastral data, a parcel block and lot number with legal boundaries has its own numerical system as well. And so this gives you an example of how this would be for a particular address with legal boundaries in Pittsburgh. Here's another way to look at finding the location and the FIPS code system. So first of all, US as the location country, and then Pennsylvania, US state 42, county 003 is Allegheny County, and then municipality 61000, and then tract 1917. Tract 1917 and block group 003, block group 003 and block 005. So we've gone into quite a small area within the city of Pittsburgh. Starting with the 2010 census, the FIPS code system was replaced with ANSI codes. ANSI codes are still based on the same naming protocol and designation system as the FIPS Federal Information Processing Standards. So now the ANSI system, which is the American National Standards Institute, has taken over from the National Institute of Standards and Technology, thus the name change. In addition, the ANSI system allows for the addition of more geographic places, features, and designations within the coding system, and it's applied across the board within the federal government. Okay, that ends the slides for this section, and next we'll talk about table joins.